Hey guys, and welcome back. All right, let's take a look at the first FX, which is the main scanning, or the two circles that we've made. You can see them there. And then we have these lines that are changing over time, and then this pattern that is also changing direction every few frames. So let's see how it's done. And it's fairly simple. So we have the point that is traveling. I'm copying a sphere to that point, and then scattering some 5 points on it, and then I'm also projecting one of the circles or the main circle, and then scattering 5 points on that as well. This enumerate function is basically doing this, so it's creating an ID attribute based on PT now. So it's exactly doing this, and because we enumerated both of them, we just need that attribute. I can merge the points on the circle, the points on the curve, and then use an add node to connect them. And then that works because these points are generated from a curve that is projected. All right, so there's this expression here that I'm using that changes the seed. As you can see, the curves are changing every 20 frames. And the way this is done is using a floor and dividing the frame. So let me remove the floor number. So let's say frame divided by 20. And if I go to frame 100, it's 5. And if I play through, you see it says 5.1, 5.2, all the way to 6. Anything between 5 and 6 has decimals. The floor function will simply remove the decimal. Will give you the closest lower value, so it will round them down, rounding the numbers. So instead of 5.2, you only get 5, and then it moves to 6. So we can say I want to randomize the seed every 20 frames, every 30 frames, using this expression. And that's what's been done here. So these points are changing every 20 frames, and then I'm using an add node with the ID used to connect them. Next is the circle, which we've done. So I have two circles projected and offsetted. And then here I'm simply adding a noise along the U coordinate. So when we resample the curve, we calculate a U attribute, and then, or a curve U, and then use that to drive a noise. So I have a noise. I'm adding it to the curve U function just to get more randomization. Instead of this, it looks like this. And then using that to drive the P scale, which goes between 0 and 1. And then when we polywire this and use the P scale, we can get thicker areas and smaller areas. All right, the next thing is the sphere. So this is the center. It's not, you can see it, but there's a sphere that actually respects the color. So if the laser, or if the laser is shining there, we're gonna see it, or have some red color around it if we want to use that, or get a close-up or something. All right, the next thing is this part, which I think is very cool. So it's all made with curves and wires. If I zoom in, there's actually geometry there. And it's done by taking two curves randomly. So I just pick 0 and 1. There's no particular order, and because they are changing, we get this. So you can pick any curves, or you can create a new one. Doesn't matter. You can create 2 points and then use those instead of 5 points. And then I'm looping over these curves, grouping the point number 0. So I have a first group now, and then I'm removing all the points. So if I display here, removing all the points except the one that hits the surface, or the tunnel, which is here. So the tunnel is here. So I have curves like that. I'm only keeping these 2 points, the tip one, which I then connect, because I only have 2 points. I then connect them and resample this to add lots of points, and then use a ray node to ray this flat curve onto the geometry. So this is the original curve, and then I ray that onto the tunnel. And that curve came by connecting the last 2 points of the original curves. So the circle is there. All right, so I have these, I have lots of points now, and I have how many? Yeah, I have thousand points, and then I want to do this. So let me show this. I'm gonna create, let's use the enumerate node, and I'm gonna say at ID points. So I have an ID attribute, and I'm going to transfer them. I'm gonna make a copy and just scale them to 0, 0, like that. And now if I merge this and this, and use an add node, and by polygon group ID, I get this. Very cool. But instead of scaling them here, I want to scale them or move them all to match the point, this point. Let me make it bigger, not this one. So point size, let's make it 10. So I want to merge all these points. Instead of moving them to this location, I want them to get the second location. So I'm going to use a point VOP, and I'm going to connect it to this input here, this point, dive inside, and then say import point attribute, and the point the ptnum, the point index is 0 because I only have one point in the second input, right? So I'm going to connect that here, and the input is second here, and then I just want to override all the points. Now if I view this, you will see that they snap to this. I can use a blend shape to show exactly this. So blend shape here. All right, so I have that, and I'm going to use a merge, connect this and this, and then use an add node. And that's how I'm building these vectors. Sorry, these points. And actually okay, we are creating these vectors just for illustration purposes. What I really want to do is I want to copy another primitive that is aligned in this direction. So what I want is to get the normal from that points from this point to this point. Let's subtract the point position from that goal and use that to be the normal. So I'm just going to connect it. I don't need to change the point position. So let's just connect that. And then I'm going to copy this line here and use a copy to points. And I want to copy the line to these points. And now they're all pointing in that direction. And I can move the curve like that. And I can make it longer. I can add more points to it. All right. So the next thing I want to do is I want to create a scale attribute. So I have these points, right? And I have this line being copied. I want to create a scale attribute. So I'm going to create a random attribute randomize. I'm going to say it's called pscale. It's per point. And let's move this to 0, 0 because we want that to be the case. And let me reverse the normal because it's pointing in the other direction. So I'm just going to flip the order. And let's make sure our normal is normalized. And now if I scale this, the scale attribute here, you will see that we get that shape. All right. So that's what's happening here. The other thing inside this is creating a ramp based on the height. So just a U coordinate basically. Let's go here. Yeah, so it's a U coordinate. And then when I copy this, because that U coordinate is the same and the curve is being stretched, we get this nice ramp. The next thing is I'm adding more randomization to the curves and using that to drive the p-scale. So on top of what we have here, I'm generating a noise that goes between 0 and 1 and using that to multiply my current color, which is the black and white ramp. And then, and then using that to drive the p-scale. Now if I do a polywire, we will get them to be thin, but also being randomized along the path and per primitive. And then I color that, connect that, merge that with the other elements. And this is our primary scanning effect. If we play it, it's gonna all be there. And then these curves, because they change, it's gonna snap. Right, and then if I go to another frame, 180, it's going to change, and so on and so forth. And now this segment here. So that's how this is done. All right. Thank you guys for watching. and see you in the next video. Bye.